Hello everyone. Thanks for coming to my talk. Good afternoon. I'm here to talk about database app development with reactive streams and virtual threads, which is a kind of a topic at the moment with the release of JDK 21. My name is Juarez Barbosa Jr. I work for Oracle as a developer evangelist with a focus on Java and database connectivity. I have over 20 years of experience in IT, several different roles, as you can see here, and I'm a frequent speaker at tech conferences as well, right? But let's get started, because that's not a talk about my profile, of course. That's not why you're here, okay? This is the agenda for us. We will talk a little bit about Java App Dev with the Oracle database, provide an overview of JDBC and how it is evolving concerning the alignment with the latest Java versions. And then present all the building blocks that we have, plenty of libraries and options for you regarding database connectivity. A comparison of both sync and asynchronous database access with Java in JDBC, of course. And a quick intro to virtual threads. Okay, of course, this is not an exhaustive talk about virtual threads. 50 minutes is not enough for that, along with the other topics that I have. But I'm pretty sure that it will provide you just a good baseline for understanding the additional topics. Okay. Virtual threads, talk a little bit about the JDK enhancement proposals. It actually supported the release of virtual threads in JDK 21, as I said. A quick comparison of Reactive JDBC, the usual sync asynchronous approach to database connectivity. And then some cool demos with the libraries that we have. The first one is the RSI library, Reactive Streams Ingestion Library. An interesting one in case you happen to need to ingest massive amounts of data with Java. And the second one, R2DBC Reactive Relational Database Connectivity as well. So it gives you options to perhaps extend reactivity to cover all the layers of your application, including the data integration layer, right? If I have time, I just want to do a shameless plug here and talk a little bit about some interesting programs that we have supported by Oracle for developers, all right? So let's get started. Regarding Java database app development with the Oracle database, it's interesting because you can see all the famous logos here, the JVM friendly languages like Kotlin, Groovy, Scala, and Java, of course. Application servers, but we have the nice frameworks for things like object relational mapping with Hibernate as a kind of de facto standard and concrete implementation of JPA. But we also see here things like Project Reactor, RX Java for reactive streams, and so on. At the end of the day, everything can be used if Oracle is the database, okay? And we have this blue arrow here with a couple of things, Oracle JDBC, our driver, of course, as usual, Java database connectivity. But we also have something called UCP, Universal Connection Pool, okay, which is an optimized connection pool to be used in case you have Oracle as a database. It's interesting if we consider as an example frameworks like Spring Boot, we have Hickory as the default connection pool and additional options for you that you can configure, like Apache CP, Bug, UCP provided by Oracle is there for you. On the right-hand side here, we have Java and the Oracle database. We call it a converged database. Why? Because at the end of the day, regardless of the data types and the workloads that you have, the data model, and the types that you have to support, Oracle has a solution for you with a single database engine. And that's great because, I don't know, maybe you are using, relational tables now, and, you have just the classic database with the database engine, but we have a requirement to support perhaps millions of users, for an internet-based application and a cloud system and so on. And you decide that perhaps NoSQL is the best option for you for this specific use case. That's also supported by Oracle. So the key benefit of using Oracle here is that you don't have to create another single point of failure in your architecture, right? As software and solutions architects, we know that every time we add another component, there are some problems and complexities that would result out of that decision. So the less moving parts that you may have, the better. Okay, so you can use Oracle. And we have plenty of options here. There's something quite interesting called blockchain tables. Okay, so if you need to leverage the characteristics of blockchain, things like traceability, non-repudiation, better security, everything, right? There's an option to create a blockchain table with Oracle, so you don't have to stand up a full-fledged, blockchain network with several nodes and possibly decide about a given protocol, or frameworks, if you like. You can also use Oracle, right? Speaking of JDBC then and support of the latest Java versions, our driver is actually compiled with Java 11 and certified with Java 17 as well. We are about to do the same with Java 21. It supports, the standards concerning JDBC, the respective JSRs with all the specifications, everything is covered. And on top of that, we also provide several extensions if you are using Oracle, right? Support to GraalVM, which is quite interesting because with GraalVM now we can do something called native image creation, and use native image compilation to create a native deployable, a software artifact that positions Java to be at the same level as other programming languages in terms of performance. Because with GraalVM, the nice thing is there are several benefits. You can get faster startup times, right? Reduce footprint, so possibly use less memory. And at the end of the day, the other resources, the underlying resources that we need for applications, processor, memory, disk, provided that you can reduce this footprint and better leverage the underlying hardware resources, you can save money, reduce costs. So that's a win-win situation for everyone, developers, organizations, and the community. Reactive schemes, our driver, interesting to mention, when you deploy the jar for that single driver, along with it, there's something called reactive extensions, okay, provided by Oracle. As part of this driver, it implements the Flow API introduced in Java SC9, so we don't have to deploy an additional jar or look for an additional implementation, just to have the basic support for reactive schemes. Okay, and interesting to mention, our driver is instrumented again and compiled with virtual class. And it also runs if you decide to create native images with GraalVM. The reason why I'm here to talk about data access, you may say, okay, I'm doing JDBC programming or JPA or using Hibernate for years now, but usually, that's something that developers, they implement the data access layer, but they forget about optimizing it. And it is really critical because you should never ever overlook your data access layer, because at the end of the day, for mission critical applications, in case you face a performance related issue at the data layer, that might propagate to other layers regarding your application, and defeat the entire purpose perhaps of having the right design patterns implemented, and your end user might end up perceiving that degradation, sacrificing the entire solution. So once again, data access is critical, so I hope the things that I will present to you here might be useful and give you some ideas to innovate on top of the options that we have. I talked about Java 21 being available now, so everything that I'm going to present here can be used with Java 21 and GraalVM, okay? That's an overview, just a block diagram with the options that we have here. We have the Oracle database on the right-hand side. You can see a dashed rectangle in red here, where we have the JDBC driver, JDBC driver, but we also have JDBC reactive extensions as an implementation of the Java Flow API, right? Beyond that, there's another option, R2DBC. R2DBC started as a Node project created by a company that, as far as I remember, got acquired by VMware. There are several implementations for different database engines related to JDBC, which provides the spec aligned with the Reactive Strings one, right? And Oracle has this project. It is open source, so you can participate, you can contribute code, you can fix bugs, right? And it's a nice option because in case you happen to have Reactive being used at other layers, it can be interesting for you maybe to consider also implementing Reactive from end to end and then have that implemented at the data access layer too. Okay? But the thing with Reactive and Reactive Strings and Reactive programming in general, it helps with things like better performance, perhaps implementing asynchronous access to codes in a kind of a file and forget approach to that, right? So we don't have to perform blocking sync calls. But with the advent of virtual threads now and the use of JDBC, we can perhaps return to adopt this strategy of implementing data access in a blocking way again. And why that's interesting? Because Reactive is powerful. By the way, don't take me wrong, I like Reactive programming. I've used other, I've worked in many projects and used several frameworks and libraries related to Reactive. But the entire Java threading model and actually all the Java tools that we have for things like debugging and performance optimizations, profiling, and so on, everything is aligned with the Java threading model. And with Reactive, the problem is that first, there's a kind of steep learning curve, so it is a little bit difficult to grasp all the concepts and learn it initially, but as software engineers, we can do that anyway. Complexity is not a problem. But the second thing is actually that with Reactive, it is difficult to debug the application because when you delegate the call to that Reactive framework, you never know exactly which thread or which component is actually executing the call, and you apply many operators, you can use the Fluent APIs with everything. But that's difficult perhaps to write and also to debug, but with blocking and programming again with threads and virtual threads, we can just go back to getting all the simplicity of using blocking data access without all the complications of adopting Reactive programming. Okay? So this comparison here concerning both approaches, synchronous and synchronous, right? When we have a system, we design the business processes, we decompose those business processes into use cases, and then we have the related functionality, right? And then I have to elect which use cases, maybe synchronous ones and which ones are good candidates to becoming the synchronous use cases, right? With Project Loom and virtual threads now, as I said, there's a way now to combine data access with lightweight threads, because that's what virtual threads will deliver at the end of the day. We are not talking about a one-to-one mapping to the underlying process, kernel OS threads anymore, in a kind of one thread or request style of fashion, right? And the client can revert to use blocking calls, again, with synchronous code, but in a lightweight way, right? Compatibility with virtual threads and JDBC, I talked about that. Again, our driver is instrumented to support virtual threads. Since version 21C of our database, we are at the moment at version 23, which is quite modern, and there's a few versions of that database, just to mention. And with reactive programming, of course, we can get all the benefits. And if you decide that perhaps virtual threads in returning to blocking is not an option for you, maybe your project or your team is highly invested in all things reactive programming. That's not a problem. Oracle, we give you choice, right? So we have RSI, we have R2DBC, the extensions that are available there by default as part of the driver. And you can, of course, combine that with the established libraries. You can see here, Project Reactor from this big ecosystem. We have RX Java, Akka, Vertex, and so on. Right? Speaking of virtual threads, of course, I assume that everyone here is a Java developer to some extent, right? So we have here the usual, the traditional, threading, thread life cycle. But the problem with classic threads when you have data access is that a JDBC call is, I would say, essentially a blocking call that can block the call, in a synchronous way for hundreds of milliseconds, depending on the non-functional requirements of your application, right? Things like performance, scalability, high availability, failover, throughput, latency, response time, you name it, right? That might not be a good option, but it changes with the use of virtual threads. Okay, all the problems that in the extension that you can see here, thread count increases linearly when we have a number of JDBC calls. We might face performance degradation, all the problems with scheduling many, heavyweight threads behind the scenes. And also in consideration of operating systems, because I don't know maybe if you are using Windows. Windows is a time-sliced operating system, so usually we have this perception or the notion that Windows is executing all the programs at the same time, but actually it is just interpolating and switching the context to give all the different programs an opportunity to execute, because that's what time slicing does, right? At the end of the day, there's a kind of algorithm, I don't know, round-robin fashion, so it shares the execution. So there are some things related to the classic platform threads and the traditional thread priorities from 1 to 10 regarding the Java.NET Advanced implementation. And with preemptive scheduling, I'm talking about systems that are POSIX related, like Unix, AIX, Linux, and so on. It might be different, okay? It will respect the priorities, but I'm talking about priorities here because at the end of the day, with virtual threads, the virtual threads, they have just one priority, low priority. It can be considered a daemon thread, okay? And that's what I have here, okay? So we can call these are first the JAPs for virtual threads, with the evolution to the final release. We have a version 4.4.4 here, released in JDBC 21, okay? But a virtual thread is just a lightweight thread then, that runs in visual mode, that will somehow try to amplify and actually better leverage the underlying resources so that you might have available for your system to have an optimized, and perhaps better flow in terms of the execution. Okay. With virtual threads, we can then revert to adopting, as I said, the approach to have blocking code, synchronous calls, because the way that the underlying thread will be mapped is totally different. Right? I have a block diagram here just to illustrate that, but essentially we have at the OS level, the OS kernel threads, right? Those will be mapped one-to-one to the classic Java platform thread, okay? But now on top of this platform thread, we can create as many virtual threads as we made, right? The nice thing about virtual threads and something that I really love, and we have to praise, the spec leaders and the people who actually collaborated towards having this release, it does not alter the Java threading model, okay? And in software, we know it is really easy for us to create and add capacity when we are creating an application, but it's difficult actually to perhaps deliver the functionality and the implementation and everything that might be needed to have a release like this one here without, being too disruptive, right? Without breaking API contracts or perhaps the SPI, the service provider interfaces, or many components that might exist, okay? But they achieved that, right? So it doesn't alter the existing implementation of threads. So Java thread is still there for you with some additional methods to support the creation in a clear way of both platform and virtual threads. with some extensions. There's a utility, a builder component as well that implements the classic Gamble for builder design pattern to to help with the creation of the specific threads that you might need, right? And that's what we have here. Actually, you can see the API here, okay, so with a link to JEP 0, which is specified what the JEP would be in the scope of the 6-month releases for Java and the way that Java transformed over the last couple of years, maybe. But you can see Java link thread here, some utility methods to check if a thread is virtual or not. It is virtual. The builders here are virtual and off platform. We start with virtual thread. My examples here, I happen to have some simple code, but just to illustrate what we are talking about, I will show you how to combine both options with blocking code in JDBC and then perhaps with reactive strings as well. Okay? Just talking a little bit more about virtual threads here. Remember, okay? So the virtual threads, they will just employ a small set of platform threads used as what we can call carrier threads. Okay, so this mapping OS kernel thread, the classic platform thread, we can call this thread a carrier thread as well. Okay, that's another way that possibly you will see that mentioned in the literature. And the current thread method will always return the thread object for the virtual thread. Okay, the get name, if you don't provide a name, initially it will return an empty information because there is never, it is not so important the way that we use virtual threads to actually understand which underlying platform thread is supporting the execution of a virtual thread depending on the specific context and the scope of execution or the flow. Okay? I talked about that. Virtual threads have a fixed thread priority that can't be changed, a low priority thread, by the way. And they are usually daemon threads, okay? An example of a non-daemon thread when we have in Java the classic Java main method, right? And that method is usually a non-daemon thread, okay? Now, just some examples of the builders, the way that you can create a virtual thread here with Java thread builder. Okay, threads of platform demo. I'm creating a demo thread start, so I can also start it right away. Okay, the second example I created, I named it due. Okay, but I need to call start to start the second example here. Okay, you can see it is really easy. Okay, we are not reinventing the wheel with virtual threads, right? And several other options here. So I just advise you to have a look at the Java doc for Java main thread. This specific one for JDBC 21, okay, and you're good to go. So this block diagram, the illustration again, you can see the OS thread, the kernel thread here. On top of that, the classic platform threads, okay. But now we have the virtual threads running, then not in a direct relationship with the underlying OS thread, one-to-one, request per style fashion, but now it runs on top of a classic Java platform thread. Okay, and that can deliver the performance and the benefits that we actually envisioned when the community started to work towards having that finalized, right? You can run it with Java 19, 20, 21 now, depending on the specific JDK, you might need to enable some additional JVM switches, as usual, or people throw tricks here. I talked about that, the JDBC driver is implemented to support virtual threads, so let's have a quick look now at one demo. Shift gears here a little bit. I just want to show you a simple implementation of virtual threads that I have here. I'm using Eclipse, by the way, okay, because I like it as a tool, and I use VS Code as well, other tools, but at the end of the day, the best tool is the one that you are most productive with, right? Okay, let me perhaps just complete, here's the font here. This class has nothing special here, okay? I call it platform threads, okay? It's just, I run just one database query, okay? Simple query. It is actually hard-coded here, okay? I start the connection just by using some specialized Oracle connection and Oracle data source classes here. But basically, we are talking about JDBC. And then I want to execute 1,500 queries here. But for each query, I'm actually allocating a platform thread, okay, the classic thread, right? The interesting thing here now, of course, this is my laptop, okay? We are not talking about a server or a cloud environment or anything, but you will see that at the moment, I have 3,790 threads, okay, or so, okay? When I start the execution with a virtual threads, then, okay, just run some simple daily experiments here, let's do it. Hopefully that is gonna work. Yeah, we will see. All right, yes, it is executing. I don't even have to wait for it to complete because now if I go there, you can see the number of threads here, 5,422. So there's actually a spike, right? A sharp increase in the number of threads, you know? We added 2,000 additional threads just to execute this simple code, right? And again, for this example here, I'm using a classic platform thread, right? I can stop it here, okay? And I have the very same example we implemented here, okay? But now I'm starting the thread with thread start virtual thread. So I'm using a virtual thread. When I stopped the execution of my previous example, you can see that actually it is stabilized. So it is back at 3,830 threads, okay? So let's do it now again with virtual threads, right? Okay? Come on. All right, yes. So I can go back to Task Manager and you can see that there is no sharp increase, no spike, okay? So now it is a simple example. So let's, imagine a situation where I have, a backend system in Java deployed to a cloud environment, and perhaps I have, thousands or millions of concurrent users, right? And I'm talking about the single class here with a single query, and you can see how evident and significant it is actually to implement and adopt virtual threads. In a situation where I have a system deployed and I have a massive number of requests, it is easy for us to see that it is actually quite important at the moment to consider the adoption of virtual threads because, again, if you can better leverage the underlying hardware resources and achieve better, latency or perhaps response time or even throughput, it is not so direct. There are many factors that might influence on such functional requirements. But at the end of the day, if I can better leverage the other resources, I'm reducing costs, I'm saving money. A win-win situation for everyone. Okay? And perhaps that's a golden pause for you now because you can go to your manager, VP of engineering, and have a conversation about virtual threads and how and why you should adopt it. Okay? But anyway, let's proceed with our conversation now. Okay, so we talked about the first approach here, synchronous JDBC, okay, blocking with virtual threads now, but request and response style, so you just send you execute the query, you get the result set, you process it, you're done, right? With reactive, it is a little bit different because it is non-blocking, so usually you can just go dispatch the call, do something else, and then it will do result, as a callback or depending on the framework, there are several different ways that it can be done, right? And now I want to talk about the options with reactive streams then. This first library here, it is actually a library that is closed source, okay? It is specific to Oracle, but anyway, if you happen to have a project where Oracle is the database and you have this requirement of ingesting massive amounts of data, it might be a good tool to have under your belt. Why? Because among all the different components that you can see here in this block diagram, there's something quite interesting called direct path insert. So when you are using RSI with Java and you're leveraging this feature provided by the Oracle database, instead of accessing and using the classic or the standard SQL mechanisms that are supported by the DBMS, the DB engine. Okay, it bypasses this mechanism. It creates the data batch in a native format, and then it inserts everything, at once, and you have that really ingested in a faster way regarding the database. Okay, I don't want to explore all the features here because I happen to have a couple of blog posts on Medium. If you go to medium.com /Oracle devs or to my profile, Juarez Junior, you will see the blog posts there. Okay, by the way, I'm a developer evangelist, so I'm always talking with developers, so if you happen to need to discuss anything related to these topics, virtual feds, reactives, strings, or something else, feel free to approach me on social media, okay, on LinkedIn or Twitter. You can just send me a connection request. I'm more than happy to support you. And if I don't have the answers, because maybe it is something too specific, I might be able to identify internally the engineer or the program manager that will provide you with the answers. Okay. So I have an example with this API here. Okay, so let's have a look. Again now. Yes. The first one is I just want to show you how easy it is to adopt RSI. Okay. This customer, it is a module here, so it is just a matter of doing a little bit of ORM, object relational mapping. There are a couple of annotations here that are specific to this API. You can see RSI here as the package, the string entity and the string field. The string entity I map it to a database table, okay, and the fields I can just map the fields, okay. After that, the second component, there are several different options that you can use with this API, okay. The easiest way to do it is to use, an out-of-the-box publisher because it uses the publish-subscribe model as of things reactive, right? Or perhaps going back to the Game of Four design patterns observer and observable, but that's the same concept. Okay, so here, the only thing I have to do actually is to create the RSI component. You can see here, there's a builder method. I specify the database connection information, URL, that's the traditional JDBC connection URL. Here I'm using, the credentials, username, password, the target schema. Okay, I can provide an executor. I'm using the standard executor here, but I can replace that with virtual feds. My second example has that, both combined. Okay, and then I execute it. Of course, I have the entity here. This is just simple mapping. Okay, this is the customer's table. I happen to have it here with some existing records. I can just delete them. And then run this query again, just to show you how easy it is to use this API for data ingestion, okay? I can run it here now. It is a quick run, or should be. Okay, so if I go to the database now, you will see that the records are there. Okay, so I inserted 6 records. And you'll say, okay, no, but 6, that's nothing, right? So I happen to have just another example here. Which is a little bit more elaborated because I have 3 different messaging protocols here. So I'm combining, reactive streams in the RSI library with the messaging protocols. I'm using a Loom component, message-oriented middleware component, that's active and queue. Okay, the protocols, they are good for messaging, but some are perhaps more aligned with things like IoT and so on. But my talk is not about the protocols specifically. I just want to emphasize to you how to use RSI. And then you can see RSI with JDBC and the ref path insert here, okay? And for this new then I can just run first ActiveMQ, okay? So I happen to have it installed and configured here. Yeah, and get this window here. Just a quick run, okay? Run, by the way, I'll start something else here. Bit easier. Okay, so I have ActiveMQ running. Okay, so for each protocol, I implemented a listener. Okay, so I just start one of the listeners here, and then I can start sending requests to ingest the data. Okay, I don't know, maybe I have this listener here. It is one for AMQP. Yeah, let me run this one here. Okay. So I'll have all the bits, the application, messaging, the APIs implemented, okay, waiting for messages. So I can now just, before I do it, let's do something here. Let me check, I think I have some, yes. Let's delete all the records here that I like to them for the database. Okay, there's nothing here, so I can just send a past request, okay, HTTP 200, okay, the status code. So if I go there now and I run the query, possibly, yeah, there's one record there. So the only thing that I modified here, perhaps I'm talking about, I'm talking about virtual threads this afternoon. I replaced JMeter with a Java application, you know, a simple class with virtual threads. So I can ingest many records, using this combination, and also RSI and the ActiveMQ message-oriented middleware. Okay, so you can see here I will just add 50 records. I'm using virtual threads here to do that. This is actually a REST request against the ActiveMQ REST API. Okay, and I provide just a standard data set here to have it ingested by the database, okay? I can quickly run it here, okay? And if I go back there now, and if I select it, you'll see that, all the 50 records are added. So it is really fast and instantaneous, okay? It's just a simple example that I'm running here, and, the runtime and the underlying platform that I have is, of course, my laptop, and it's just a simple computer, but I advise you to have an experience and perhaps try to run the examples with these RSI. Yes, I forgot to talk about that. This is the structure for the project. You can see the three different listeners for AMQP and QTT and Stone. Okay, the retailer is actually the class that I can use with those annotations that I showed you to map it to a database table. The message producer, that's actually JMS, as usual, Java Message Service. And the RSI, okay, RSI service, that's the type that I implemented. Okay, of course, with that, you can create data-related many things, with different protocols, so in combination and also considering the use of Oracle Cloud Infrastructure, which is our cloud environment as well, okay, that it's there for you. The last one that I have to talk here this evening is R2DBC, Reactive Relational Database Connectivity, okay. It's interesting, this one is open source, as I said, okay, you can see the OSS, open source software, Apache V2 at the bottom, okay, runs on Java 11 plus, right? We released version 1.1.1 in March this year, okay? It's quite solid, rock solid library for you. And it works with the JDBC driver, and as I said, you can implement a reactivity with this one. The good thing is that R2DBC allows you to combine it with the libraries that are the ones adopted by the community at the moment. But again, Project Reactor, Vertex, RxJava. An example with Reactor here, you can see Flux, okay? So it is as easy as that. I get the JDBC connection, of course. I can create a statement or a preparative statement. And then I can apply, I apply using the Fluent interface API, the operators, as usual, the reactive programming. And that's it. I can process the results. Okay? I have just this simple example here as well. No tricks here. Okay, what is it? Yes. If I go to, let's see. Yes. This one here, you will see, I just, pretty much the same code, but I'm using here, Reactor with model and Reactor with Flux, and I process the results, okay? I can run it against the database that I just added some records with the RSI library, and I just, return the IDs, but you can see that it works. Okay, so the purpose is just to show you that R2DBC is another option that you might want to have a look. Okay, so And that's the end of this discussion. Virtual paths for Reactive, okay? Oracle JDBC and Oracle, we support both. Again, Oracle does everything that is possible to provide developers choice, okay? The driver has been instrumented and it is compatible with virtual paths, okay? And if you want Reactive, you have the options that I presented, okay? And this comparison matrix. Benefits of virtual paths, again, easier to read and write, easier to debug. Integration with the JDK tools. Remember that, doing blocking programming, the traditional way of doing that instead of adopting Reactive, it is far easier than, the problems that we have here, delegating the calls to, underlying components and everything else that I talk about this afternoon. Okay? Limitations of virtual paths. Actually, now I moved because it was not available yet in JDK 21, but that changed recently. So that's actually a benefit. It is available in JDK 21 now. Okay? Of course, some libraries and frameworks are not compatible yet. Okay, if you have libraries or implementations using things like synchronized code, you might need to have a look at that. But there are several projects implementing virtual paths now. An example, Tomcat 10 is now compatible with virtual paths. We have Quarkus released with that Alidon 4, which happens to be an amazing framework supported and developed by Oracle. Oracle Labs, our research and development arm. We have Micronaut, and we happen to have an amazing speaker here at the event. Alvaro, I do advise you to have a look and actually participate in his presentation this evening, okay? Because he will talk about Robbie and Micronaut is simply amazing. And limitations, benefits of Reactive. You can, of course, avail and get the benefits of the established libraries, use the Stream-like API with functional style, low-level accuracy is handled for you. Okay, you can abstract and you can avoid that complexity, but if you have to debug it, that might be a problem. And that's one of the limitations that we have here is deep learning curve, harder to read and write and harder to debug. Okay? In consideration of the topics here, there are some technical references here for you. Okay, if you want to get a hold of this deck as well, just reach out to me and I will send you a link. But I advise you to have a look at the topics here, including this blog post, the arrival of JDK 21, where we have all the gaps specified there with the relevant links as well. Yes, speaking of the Oracle database, there's a free developer release. Some people, are not aware of that, but it's interesting. All the features that are available as part of the cloud database that we have, version 23C, they are actually included as part of this free developer release version. Okay, so go and have a look at it. And you can, of course, run the examples if you go to Medium and if you go to my GitHub, just reproduce everything that I presented here. Oracle Live Labs, that's nice because these are actually free workshops provided by Oracle, okay? Not only regarding Java, we have Python, Golang, DevOps, Micronaut, Alidon, Spring Boot, Cloud Native, you name it, okay? Free, everything is free, okay? So have a look at, go to developer.oracle.com/live labs. And the Oracle ACE program, this is a program for distinguished community members. Okay, so maybe, and it is not limited to Oracle. If you are doing things related to, maybe open source, Python, Linux, there are plenty of opportunities for you there with 3 different levels and membership tiers here, Associate, Pro, and Director. Okay, it's nice because you will establish a relationship with Oracle and participating in some internal, resource programs, and also perhaps participate to support some technical events as well. Many different things might happen out of this, Oracle ACE program. In terms of nomination, if you think you have, contributions that might be, aligned with the scope of this program, of course you can go and check. Feel free to approach me as well. I'm more than happy to work with you and relate to become our colleagues with our profession. All right. Last thing, Oracle has a cloud, Oracle Cloud Infrastructure, Generation 2, by the way, redesigned from scratch. Okay, and you know, with the best approaches to many things. Some people don't know about that, but I do advise you to have them on CI. And there's an always free version of it with some services like databases, VM, and things that you can actually use for free. There's, of course, utilization threshold, but it might be useful for you in case you have that side project and you need, cloud environment to host it. All right. That's my talk then. Thank you very much, folks. And as I said, if you want to, have a conversation with me about any of these topics, feel free to approach me during the conference or on social media. We can talk over coffee or but that's it. I hope you like the talk, okay? And again, mission critical applications, okay? Data access is important, so never overlook. All right. Thank you very much.